All right. So my name's Sebastian White, and I'm here today to talk about PowerLab C in the C series, which is the next generation of research hardware that's coming soon from ADInstruments. So I'm going to, just to give you a bit of an overview of what I'm going to cover today, I'm going to first off talk a little bit about what the PowerLab is. So I'm sort of assuming that most of the people on the call today are going to be vaguely familiar with ADInstruments and what we do, so I won't spend too much time on that. But the main point of that was just to lead into why we feel like we need to make some changes to the PowerLab, and then I'm going to move on to introducing the PowerLab C and the C series products and go into a little bit of detail on them. I'll touch briefly on the future of the product range, and then at the end there'll be some time for questions and discussions as was just mentioned. So I'll try not to take up my full 45 minutes just talking, and hopefully we can have a bit of discussion, questions, or I'm always glad to hear any feedback that anyone's got at the end as well. So first off, just a little bit about myself. So my title is Research Product Manager. I am based in Sydney, Australia, and yes, it is nighttime at the moment, but that's okay. I'm glad to be here. And I've been at ADI for almost 10 years now. I began as in a technical sales role here in Australia, and I moved on to a training and support role that covered Australia and a lot of Southeast Asia. So there's a lot of good travel during that time. But for the last few years, I've been in a product manager role, responsible for a good chunk of ADI's research hardware. So that's enough about me. I'll talk a little bit about what a PowerLab is. So the PowerLab has been ADI's core hardware product for over 30 years now. If I need to put into one sentence what it is, it's a data acquisition system for time series life sciences data. So it's all about sampling a whole bunch of different time synchronized data and getting it into the lab chart software. It is a fully software controlled hardware, and I think that's something, that's one of the reasons why we've been successful, is that our hardware is fully software controlled and we're able to leverage that ease of use that you get out of a lab chart and the ability to save settings into the software and things like that. So I hope most of you will agree that the PowerLabs can sort of be characterized as being simple, reliable, flexible, and trusted devices, and have been for a long time. So what's changed then? I mentioned that PowerLabs have been around for 30 years, and obviously some things have changed in that 30 years. So obviously the technology under the hood has evolved. So over time we've upgraded the guts of the PowerLab as technology has moved along and kept up with that. We've also built out ADI's range of amplifiers and instruments and transducers. So we've developed an ever-increasing number of different devices that you might want to connect into a PowerLab and use in a laboratory. We've also expanded the collection of third-party instrument makers that we work with. There's a whole range of instruments made by other people that also work really well when connected into the PowerLab, and then that data is recorded into the lab chart software. And of course, the lab chart software itself has evolved dramatically in that period as well. And I mean, honestly, that's probably where most of the work has gone into improving lab chart over the years. But all that said, the core idea of what a PowerLab is hasn't really changed in those 30 years. So all along, as you can see at the bottom there, it's been basically a box with some input connectors at the front where you can plug other devices in, and then a way of connecting that into the computer at the back to then use with the lab chart software. Where's my button? There we go. So that's sort of where we've come from. So why do we feel like it's time for a change now? The main reason really is that traditional PowerLabs are perfect for integrating analog devices. And in the past, analog BNC outputs were kind of the de facto standard on lab equipment. And the PowerLab was really the ideal device for being at the center of a research lab. When you had a whole range of different instruments or transducers that had a BNC output on them, the PowerLab was just the ideal thing to have in the middle of that lab to allow you to record all that data, get it onto the computer, and then do the analysis that someone might want to do. But as we're all aware, we don't live in that world anymore. Things have moved on, and many newer instruments in the market are now digital devices. They might connect via USB or Bluetooth or some other digital way of connecting up to a computer. And so the PowerLab in its traditional form is less useful there. Even many of our own newer devices are digital devices. and they connect directly to LabChat via USB and don't need to connect through the PowerLab anymore. So it's sort of clear to us that the industry's headed in that kind of digital first direction. So the question for us really when we were thinking about the future of the PowerLab was how do we bring the benefits of the PowerLab and what's good about the PowerLab, and how do we bring that into this digital first world. So while we're doing that, we tried to keep in mind the things that shouldn't change, the things that were good about the existing PowerLab. And the first one that I've got on my list here, of just a few of them, is synchronization. So this is something that we sort of took for granted in the world of the traditional PowerLab, where you could just plug in a bunch of different stuff into your PowerLab, and it was just natural that the recordings from all those different devices would come up synchronized in time in the LabChat software. And even though it was easy to take that for granted, that was something I think was really valuable to people who used our equipment, that that data was always in pretty much perfect time synchronization with the with all the other signals from the lab. That isn't something that you can take for granted in a digital world, though. It's actually quite a technically difficult problem to solve in the digital world, at least to the level of sort of accuracy of time synchronization that the type of work that people would do with a PowerLab requires. So that's something that is always on our mind at ADInstruments in both the software design side of things and also on the hardware side of things. So synchronization is really important. The simplicity angle, I think, is also important. I think that's a big reason why people like the PowerLab, is because it is simple. It's just a box with a bunch of inputs on it that you can plug in whatever you need, and then all of that can be configured really nicely and easily within the LabChat software. So that was something that we wanted to keep. The last one I've got here is power. So again, mentioning the LabChat software there, which is sort of where a lot of that power comes from. But also thinking about this idea that the system should scale from something simple up to something quite advanced and powerful. So we know we have some customers who might only want to record 1 or 2 different signals, and that's fine. But all the way up, we have applications all the way up to recording dozens of different signals and from a range of different instruments. And we wanted to make sure we had in mind that entire spectrum of different use cases there. All right, so what did we come up with? We've come up with 3 new devices that I'm going to introduce and talk a little bit about today. The first one's the PowerLab C itself, and then I've also got a device called the Frontend Interface and a third device called the Instrument Interface, and I'll talk about each of those devices in turn. But yeah, so this was my slide about the PowerLab C, facilitating a simple, reliable, low latency connection between digital devices. Once again, the center of the Life Science Research Lab. So this is an image of the front of it, which if you could have seen the image, you would have noticed is different from a traditional PowerLab in that there's nothing on the front. So now hopefully you can see this. This is an image here of the back of the PowerLab device. So on the left-hand side here, there's a whole bunch of USB Type-C ports. And on the right, we've got our a familiar power inlet on the right-hand side there. So first up, I'll talk about this top row of 4 ports, which, as I said, are USB Type-C ports, and we call these the downstream facing ports. And they're the ones that you connect up to additional C-series devices where the data actually comes from. So each of these 4 ports provides up to 90 watts of power via the USB power delivery or USB PD standard, which is an industry standard that's used in a lot of in the consumer electronics world for squeezing a fairly large amount of power down that common USB-C cable that I'm sure you're all familiar with. We also get USB data through these, so the actual data itself comes through a standard USB connection. They also support ADI alternate mode, which is a thing I'll talk about in a little bit more detail later on. And really the long and the short of it is that each of these ports can facilitate up to 8 channels of data coming into it. So with the 4 ports, we've sort of got up to 32 channels of data in the traditional sense that you'd be used to with an existing PowerLab. But these are of course digital ports that work differently than the traditional PowerLab ports. So that's the 4 main downstream facing ports on the PowerLab. So next up, I'll talk about the rest of the connections on here. And most of these are really just about providing power to the PowerLab. So the PowerLab can be powered in one of 3 different ways. The first is through the mains inlet, which is the way we expect most people to use it and the way people use PowerLabs today. It's just powered through the wall. But there are also 2 additional USB-C ports down here. So the computer port at the bottom left here is the port that will connect up to the computer that's running LabChart. But if you've got a compatible Mac or PC, you'll also be able to power the PowerLab itself directly from that computer, just with that one cable, without needing to worry about an additional power supply. We also have the auxiliary power input here, which sort of, as the name implies, is just a third way of powering the device. And this is compatible with any USB PD compliant power supply that's out there. So that's things like car chargers, things like battery packs that you'll see around all over the place, or things like existing laptop chargers that you might have for a modern laptop computer. I've also put on here that the PowerLab C itself can power your laptop. So if you have this thing powered through the auxiliary port or the mains port, then one of the downstream facing ports can be used to power your laptop as well. So we think this will open up some interesting kind of portability options here, with being able to have an entire stack of ADInstruments equipment and a laptop potentially powered just off a USB battery pack that someone might have around anyway. So we think that's going to be an interesting new use case for the PowerLab. So yeah, that's a summary of the PowerLab C. Quite a simple device, just a bunch of USB Type-C ports at the back and a power input, and of course the very exciting cooling fan. So next up, the front-end interface. And the front-end interface has quite a simple purpose. It's intended to convert existing ADInstruments front ends. So those are all the different types of amplifiers that we sell, things like bridge amps and bioamplifiers and GSR amps and those sorts of things. And it converts all of our existing front ends to work with the PowerLab C. So this device actually does some analog sampling in the traditional sense, and we can sample up to 8 channels at a sample rate of 50 kilohertz or 4 at 100 kilohertz. And it supports all the currently shipping front ends that are available from ADInstruments, as well as the vast majority of legacy ones. And that was something that was quite important to us, because we know that a lot of our customers have built up quite a collection of different ADI gear over the years. And we really wanted to make sure that there was nothing that people needed to throw away if they moved on to a new generation of hardware here, that there'd be a lot of existing equipment that could be used to build a more advanced setup rather than needing to throw out some equipment and replace it. So that was something that was important to us. So we do support 1, 2, 4, and 8 channel front ends using this device, just using a different cable assembly. So this is a picture of the front-end interface sort of in action here. So the big silver box here is a bridge amplifier, and I've got the front of that device up here. So this is an amplifier that you'd use for connecting things like pressure transducers, or force transducers, or temperature sensors, those types of things. And this is what the back of it looks like with the front-end interface connected. So you can see the interface connects at the bottom left here to the to that 9-pin I2C port that exists on all our front ends. We've then got a cable assembly here coming from the bottom left of the front-end interface. This is the 8-channel variant, of course. You can see the 8 different B and C connectors that plug into the front end here. And then here we've got the USB Type-C port that connects off, and that would plug into a PowerLab C off to the left of screen there. So we think it looks reasonably elegant connected on the back of the front end here, and when you turn that around the way that you normally have it, you probably won't even notice that it's connected. And you just need that one USB Type-C cable going to the PowerLab C to provide power and data and all that stuff. So that's the front-end interface in a nutshell, fairly straightforward. So next up is the instrument interface. And this device is intended to provide 4 channels of analog input capability to the PowerLab C. So this device also samples analog data in the way that a traditional PowerLab would. And it can sample up to 100 kilohertz sampling rate on 4 channels. And it's got some preamplifiers built into it as well to support a range of different instruments. And yeah, it is intended for connection to a range of different analog instruments. That includes the number of different brands that we sell, things like Transonic or AM Systems or Warner or Miller, but obviously it can support whatever analog devices our customers might have in their labs as well. So from a usability point of view, it's a fairly simple device. It's just got the 4 B and C connectors at the front, and it's got this one USB Type-C port at the back. So it's really quite a straightforward device from the outside, at least. Okay, so that is the instrument interface. Next up, I wanted to talk about ADI alternate mode, which I mentioned briefly on the PowerLab C slide. And this is a feature that we're pretty excited about for the future. So what ADI alternate mode is a way for all of the C-series devices that I've spoken about so far to communicate with each other over an Ethernet link that shares that same USB cable. So this one USB cable that we've got going between devices not only provides power and the normal USB communication with the data coming back and forth, it also provides this Ethernet link that allows the hardware devices to communicate with each other. And the cool thing about this link is that it's a very low latency link. So it's going to allow us to send messages between the devices and do some advanced kind of real-time stuff with these devices able to communicate with each other. So to start off with, we've only got a couple of features that are making use of that. One of these is time synchronization. So when the C-series devices connect into the PowerLab C, they actually all communicate with each other and synchronize their clocks down to the order of hundreds of nanoseconds, which means that we can have that experience of data recorded in the lab chart being perfectly synced up in time. The other feature that is sort of related to alternate mode is the adaptive mains filter. This is something that exists in our current range of PowerLabs, and it's just the ability to filter out noise that might be coming from the mains power supply, and the filter adapts to whatever the mains is doing in the particular area that you're in at that particular time. And this is something that we think is really commonly used. And bringing that into this kind of digital architecture was, again, not a technically easy or not a technically simple thing to do, but it's something that we've made sure to bring across as part of ADI alternate mode here. But what we're most excited about with alternate mode really is what we're going to be able to do in the future as we build out the number of C-series devices that exist and have them doing a wider variety of different things. We think there's going to be some pretty cool stuff that we can bring out in the future that makes use of this ability of the devices to talk to each other. All right. So having said all that, I just wanted to talk about the front-end interface again briefly, now that I've talked about alternate mode. So the front-end interface, which is the second device I mentioned before, is designed to work with the PowerLab C. And when you use it with the PowerLab C, you get the benefits of the adaptive mains filtering that I just spoke about. You get that sub-microsecond time synchronization with other C-series devices. And you can also make use of all those power supply options on the PowerLab C that I spoke about to allow you to power whatever front end you might decide to connect into it. All that being said, though, it is possible to also connect the front-end interface directly to a computer. And I think this will be really great for people wanting a nice, simple, small setup. So there's an example of that in the picture on the right here, where you can see that we've just got a spirometer set up. So this is a flow head at the front where someone would breathe into and they're doing a simple spirometry experiment. And you notice at the back here, there's a front-end interface connected, and there's just one cable going from the front-end interface into the laptop running Lightning here. And this is now a complete functional setup without the need for any additional equipment. So again, we think that's going to be really useful for people who are just doing a more simple experiment. Along very similar lines, the instrument interface is also primarily designed to be used with the PowerLab C, and you get that benefit of the mains filtering and the time sync. But it can also be connected directly to a PC using just that one USB Type-C cable for simple setups. So again, I've got an image here showing a Warner amplifier that's used for electrophysiology work that's connected up to the instrument interface with a single cable going into the laptop running LabChat Lightning. And again, that's a complete functional setup. And just to show what it would look like if someone were to try to build up the complexity a step and use both these devices together, you would then have a stack that looked like this. So you can see a PowerLab C at the bottom of the stack here, the instrument interface and Warner equipment on the left, sorry, and the spirometer and the flow head on the right, with the front end interface connected at the back. So this still ends up being a pretty neat and clean stack, I think. And the idea here is, of course, that this is sort of infinitely scalable. You can add as many PowerLabs and as many different types of amplifiers in a stack here as you need to do the type of work that you want, with all that data flowing into LabChat running on the PC. All right. So just to summarize the the shared features of the system here. So all of the devices I've talked about today are powered by industry standard USB PD. They all support adaptive mains filtering when used with a mains powered PowerLab C. They all support ADI alternate mode for this inter-device communication, which, as I've said initially, is all about time synchronization, but we'll probably do a lot more in the future. All the devices are fully software controlled in both LabChat 8 and LabChat Lightning. All of these devices are compliant with the IEC 60601 standard. So that's the medical device electrical safety standard that we test all of our devices that could be potentially connected up to a human to. And all the devices also offer a 5-year warranty, which again is just what we offer for all of our research hardware. So just to kind of tie this back to what I was talking about at the beginning in terms of what we've thought about PowerLabs and what's been good about them, these are kind of 4 key characteristics that we think kind of summarize what the C series and the PowerLab C is. The first one there is a digital framework for the future. So that's been hopefully clear all along, that we're really trying to embrace this digital first world and build a foundation there that we can build on into the future. It is a modular system, which I think is a really big advantage to be able to scale a lot more than we ever could with our old range of equipment, right from a simple system with just 1 or 2 channels of data all the way up to, you know, stacks of equipment to record a whole bunch of different parameters at the same time. And I mean, that's only going to grow in the future as we add more C-series devices. Powerful and portable. Again, I think that portable angle of being able to power the stack of equipment in a variety of different ways will give people more flexibility, and I'm interested to see how people end up using that. And also, well, hopefully we all agree it's going to be as powerful a system as we're used to with the traditional PowerLab. And the last one here is analog compatible. So with all this talk about digital, we obviously haven't forgotten that there's still a huge number of analog instruments out there, some of which we continue to sell. And we know that our customers have heaps of different analog devices in their labs, and it'll be, and we haven't forgotten about that. The PowerLab C works nicely with all those devices as well. So having said all that good stuff about the PowerLab C, what's missing? And if anyone who's on the call is familiar with existing PowerLabs at the moment, you'll probably already have noticed what's missing. So one of the things is the TTL input and output. And these are these little sort of D-shaped connectors at the back of the PowerLab 35 that are used for sending event markers in and out of the system. And we currently don't have an analog for that in the PowerLab C line. There's also no voltage outputs. So the little voltage outputs at the front of the PowerLab, there's no equivalent to those at the moment in the C series. And there's also no support for smart transducers or pods. I won't go into detail on that, but if anyone's got any questions, feel free to drop them in there and I can talk in more detail about support for any specific pods or smart transducers. But the key point of this slide anyway is that the 35 series PowerLab isn't going anywhere. We recognize that it's going to be a great choice for some people for a while to come, so it's not going anywhere. And also worth pointing out that it will work perfectly alongside C-series equipment. So there's no reason to have to choose one or the other. They'll all work nicely together. LabChat will just sample data from all of the connected PowerLab devices, whether they be traditional devices or C-series devices. Okay, so I'll talk a little bit about the future. So hopefully you would have gathered by now that we really think of these 3 products as just the foundation, just the beginning, and they are built with the future in mind. So a lot of aspects of the product are over-engineered, things like the power supply technologies that we built into the PowerLab C, all of that's over-engineered so that we can leverage that in the future. And we're really hoping that we've built a really solid foundation here for many future products to come. Particularly ADI alternate mode, I think will get much more interesting once we add on the next wave of C-series products in and build out this product range even more. And we really hope that this will set us up for years to come and be useful for our customers for years to come. So that's all I had, and hopefully I didn't sound hopefully some of you guys are a little bit excited about the future of ADI research hardware as well. I know I've been working on this for a long time, and I'm pretty excited about what we've got coming out. Here. So all I have now is just open it up for questions and discussion. I'm happy to spend the next, what have I got, 10 or 15 minutes left. Happy to answer any questions or have a discussion with anyone.
So in the meantime, I had personally a question with regards to the PowerLabs. I'm curious about how it works, and I was wondering, you mentioned that it could be powered from different ways, and I was wondering what would happen if you were to swap from a power source to another one while recording.
Yep. So we have thought about that, and as long as there's enough power available from a secondary device, it'll switch over seamlessly from using one power supply to another without dropping any samples. There is a little bit of complexity there to do with power budgets, and depending on how much power is available from the laptop or the battery pack that's been connected up to the device. But assuming that there's sufficient power available, the switchover should be pretty seamless.
Good to know.
Sebastian, you mentioned that you can stack PowerLab Cs together. Can you talk about if there are any, let's say, physical limitations or software limitations, either LabChat 8 or Lightning, when it comes to stacking up PowerLabs to increase channel number?
Sure. So yeah, the PowerLab C is designed to be stacked up. So by default, those 4 ports allow sort of up to 32 channels of data, depending on the devices that are connected. And you can just connect one downstream port from one PowerLab into the computer port of the next PowerLab and stack up as many as you need. So with LabChat 8, we still have a 32 channel limitation in software, and that limitation will apply to your stack of C-series equipment. But in LabChat Lightning, we have a much higher limit of channels. I think we sell it as unlimited, which is maybe we don't want anyone to test whether you can really get to, I don't know, 1 million or something on it, but theoretically you've got an unlimited number of channels if you're using LabChat Lightning and stacking up C-series equipment. You just have to give a little bit of consideration to your power supplies there again. Make sure that you're giving the system enough power inputs.
We had another question in the chat. So this is with regards to the USB-C. If the computer is not equipped with a USB-C port, is there any other options?
Yeah, that's a good question. So that computer port that I showed can plug perfectly fine into a traditional USB port, and we'll even ship a cable in the box to go from the C port on the back of the PowerLab to a traditional type A port that an older laptop might have. The only thing you don't get there is the power supply side of things. So if you've got an older computer with only a traditional USB port, you'll just have to power it using mains power or a battery pack. You won't be able to power the PowerLab directly from your laptop. That'll only work with newer machines with that type C port.
Thank you.